Hi guys, it's Mrs. Harmison here with your Chemistry 4A notes. These notes are over solutions and solution calculations. In this beaker we have a solution. In the solution there is a solvent. That solvent is usually water, and the solvent is what does the dissolving. There's more of the solvent than there is of the solute in the solution. The solute is dissolved in the solvent. A solution with a relatively small amount of solute for the amount of solvent is a dilute solution. A solution with a relatively large amount of solute for the amount of solvent is a concentrated solution. The definition of solubility is the maximum amount of solute that will dissolve in a given amount of solvent at a given temperature. In an unsaturated solution, the concentration of the solution is less than the solubility for that temperature. In a saturated solution, the concentration of the solution is equal to the solubility for that temperature. And in a supersaturated solution, the concentration of the solution is greater than the solubility for that temperature. Sometimes you can have a solution made of two different liquids. When that happens, the liquid that there is more of is the solvent, and the liquid that there is less of is the solute. When two liquids dissolve completely in one another, we call them miscible. When two liquids are insoluble with one another, we call them immiscible. The equations that you're going to need to do this lesson are on this page. Molarity, which is abbreviated with a capital M, is equal to the moles of solute divided by the liters of solution. The second equation is for percent by mass. When you do percent by mass, you're going to take the grams of the solute divided by the grams of the solution times 100 to make it a percentage. The solution is the solute plus the solvent. You're also going to need to know how to convert from moles to grams and grams to moles. So if we had 4.5 moles hydrosulfuric acid and we wanted to convert that to grams, since moles are here, we would put 1 mole down here, and then we would add up the molar mass of hydrosulfuric acid. So we would take 2 times the mass of hydrogen from the periodic table, 1.01, plus 32.06, and we would get 34.08. And we would put that up here. 34.08 grams is equal to 1 mole. We would get 1530 grams of H2S. If we wanted to convert 14.5 grams of CaOH to moles, we would do the opposite. Here we multiplied by the molar mass. Now we're going to need to divide by the molar mass. And we would get 74.1 grams per 1 mole. And our answer would be 0.196 moles of calcium hydroxide. In this problem, we have this kind of crazy looking compound, but if you break it down, it's really just ammonium and acetate. But for these problems where we're dealing with the percent by weight, we don't even have to worry about what the compound is. We know that this one has a 10.6% by weight. Our percent by weight formula is grams of solute over grams of solution. And it's telling us up here that we have 196 grams of aqueous solution. So we're going to put that down here for the grams of solution. Oh yes, and our equation has to have times 100. What we're trying to find is how many grams of this there are. That's going to be our solute. So we put an X up there, multiply by 100, and then we just solve. So we'll take 10.6 divided by 100 times 196, and you end up with 20.8 grams. Okay, this problem tells us that we need to make an aqueous solution of 0.202 molar calcium nitrate. We're going to have to use the molarity equation. So we're going to put this 0.202 in for the capital M. Since it asks how much solid calcium nitrate should I add, I want to solve for that in grams. But in order to get to grams, I need to solve for moles. So moles is what we're trying to find here. And we are given 250 milliliters as our volume. So this is in milliliters. We need it in liters. So we're going to take 250 and go from milliliters to liters. So 3 to the left, move the decimal, and we get 0.250 liters To solve for moles, we take 0.250 times 0.202, and we get 0.0505 moles. We want to change this to grams, so we're going to have to write the chemical formula for calcium nitrate. Calcium has a +2 charge, nitrate is a polyatomic ion, NO3, so we switch those charges and we get Ca parentheses NO3 2. Moles are here, so we put 1 mole down here, and up here we're going to put the molar mass of calcium nitrate. So up here we put 164.1 grams, and we get an answer of 20.8 grams. Okay, this problem is also giving us a molarity, so we're going to have to use our molarity equation. This time it's asking us to find the volume. I'm going to plug in 0.237 for the molarity, and I am going to try to solve for the liters. So what we need is the moles. We're given a mass, so we can take 6.69 grams of copper 2 fluoride. Now copper is Cu +2 because of the 2 in the parentheses. Fluorine is a -1, so we get CuF2. We have grams here, so we need grams down here, so we need to add up the molar mass of copper fluoride. We put the grams down here, 1 mole up here. We get 0.06588 moles. We can put that number right up here, and then we can solve for liters. So we take this number divided by this number, and for liters we get 3.60 liters. Now the problem, as you can see, is asking for milliliters, so we have to slide the decimal 3 to the right, and we end up with 3,600 milliliters. Okay, this problem is asking for us to solve for molarity. For molarity we need moles and we need liters. We don't have either one of those, but we can change grams to moles and we can change milliliters to liters. So let's start with changing this grams to moles. 13.2 grams of sodium fluoride. We need to add up the molar mass of sodium fluoride. So we put 41.99 here, 1 mole up here. We get 0.3144 moles. So that's going to be our top number. Now we need the liters. If we have 500 milliliters, we just slide 3 to the left to get liters. So we have 0.5 liters. When we take 0.3144 divided by 0.5, we get 0.629 molar. All right, this one asks if we have a solution of Ca3PO4 and it has a concentration of 2 molar, what is the concentration of each of the ions present in the solution? So we have this calcium phosphate, and this 3 tells me that in 1 mole of calcium phosphate, there are 3 moles of calcium ions. And this 2 tells us that that's also equal to 2 moles of phosphate ions. If the concentration of the whole solution is 2 molar, that means there are 2 moles for every liter of calcium phosphate. We want to find the concentration of the calcium ions and the concentration of the phosphate ions. And these brackets, those mean concentration of. So the concentration of calcium ions, because there are 3 moles for every 1 mole of calcium phosphate, we would take 2 molar times 3 and get 6.0 molar. For the concentration of the phosphate ions, we have 2 moles for every 1 mole of calcium phosphate, so we would take 2 times 2.0 and get 4.0 molar. All right, this problem gives us 20.2 grams of calcium nitrate. Calcium nitrate we used earlier in these notes, and it tells us that we have 250 milliliters of this, and it asks for a molarity. So molarity is moles per liter, so we need to convert this to moles. Now, moles divided by liters is molarity, so if we move this decimal 3 to the left, we can divide our moles by 0.25 liters, and we can get a molarity of 0.492 molar. That's the molarity for calcium nitrate, so that's what we would put right here. Now, every 1 mole of calcium nitrate has 1 mole of calcium and 2 moles of nitrate. So we would have to take 0.492 times 1 to get calcium's molarity. So 0.492 would also go here. And then we would have to take 0.492 times 2, because there are 2 moles of nitrate for every 1 mole of calcium, and get 0.984 molar nitrate.